In section 4.3, you are going to learn the last way to solve a system of equations, and that is by using the elimination method. Now, this is also called the addition method or linear combination. Personally, I like to use the addition method or the elimination method better. But when you use the addition method, you are eliminating a variable in the process. So, under the solve it problem, what I want you to do is write the steps on how to solve these. Step 1. You are going to align the equation. And by that, I mean you need to make sure your x's, your y's, your equal sign, and your constants are all lined up. The best way to do that is to put it in standard form. Step 2. This is optional. This is not going to happen every time. You want to make sure that you have to multiply the equation or equations by a factor to make one of the variables have coefficient that are opposites of each other. For example, if one coefficient is 6y, the other one needs to be negative 6y. If one is negative 3y, the other needs to be positive 3y. You want them to have opposite coefficients so they are eliminated. Step 3, you add the equations together to eliminate a variable. And step 4 is to solve. All right, let's look at problem A. Problem A is 5x minus 6y equals negative 32. And 3x plus 6y equals 48. You will notice that both of these are in standard form. And if you look at the x's, they're not going to cancel. But you have to look at the y's. You have a negative 6 and a positive 6. They're completely opposite coefficients. Therefore, these are going to cancel. You have to make sure before you go any further, something has to cancel. And so because these are the same, the y's are going to cancel. Step 2, we don't have to do. Step 3, just add them together to make one of the variables cancel. 5x plus 3x is 8x. That's negative 6y plus 6y is just 0y. And 48 minus 32 gives you 16. Now you just solve the equation. You're going to get the value of x is equal to 2. But we still need y. This is where it takes a little more work than substitution. Take the value of 2 and plug it into either equation. It does not matter. To me, it looks like the second equation is easier. So I'm going to take 3x, well we know x is 2, so I just plug it in, plus 6y equals 48. That gives me 6 plus 6y equals 48. Subtract 6. 6y equals 42. Divide by 6, and my y value is 7. So my answer is 2, 7. The value of x is 2, and the value of y is 7. If you wanted to check your answer, you could take both of those values and plug them in to either one of these equations, and they should both be true. Example B. Example B, everything is lined up, and if you notice, our x's this time have opposite coefficients. So step 1 and step 2 we don't even have to do. Step 3, add them up. X's cancel. Negative 3y and negative 4y is negative 7y. 9 plus 5 is 14. I divide both sides by negative 7. That gives me a value of negative 2 for y. I now take the value of y and I plug it in either here or here. So I think the second one to me looks easier. So I'm going to take 3x minus 4 times y, which I found as negative 2, equals 5. That gives me 3x plus 8 equals 5. Subtract 8. 3x equals negative 3. X equals negative 1. So my answer would be negative 1, negative 2. Example number 1. Same thing. Step 1 and step 2 are already done for us. Add them together. What would you get? 4x equals 16. Divide by 4, x would be what? 4. Plug the 4 in. I'm going to plug it into the top here. 3 times 4, that gives me 12. Plus 3y equals 27. Solve the remainder of the equation. You get y equals 5. Therefore, your answer is 4, 5. In problem 2, we're going to use word problems. So let's look at the got it. Washing 2 cars and 3 trucks takes 130 minutes. Washing 2 cars and 5 trucks takes 190 minutes. How long does it take to wash each type of vehicle? First thing, write your equations. So I'm going to use C and T. 2 cars and 3 trucks takes 130 minutes. Washing 2 cars and 5 trucks takes 190 minutes. All right, so step 1. Align everything. Everything is lined up, ready to go. But here's our problem. If I add these together, 2C's plus 2C is going to give me 4C. 3T plus 5T gives me 8T. Nothing's going to cancel, which doesn't help me. So you have to multiply by something to get either the C's to cancel or the T's. Now the C's look much easier to cancel because one's 2C. To get the opposite, one would have to be negative 2C. So what would you multiply to either one of these to make it cancel? You would need to multiply one of them by negative 1. Now it doesn't matter which one. It really doesn't. I'm going to multiply the first one by negative 1. Now notice what I'm going to do. I'm going to actually write both of these again over to the right. The reason is it keeps me organized. So then I don't have a whole bunch of equations in a row and then I don't know what I'm supposed to do. So I'm going to get negative 2C, multiply everything by negative 1, minus 3T equals negative 130. The second equation doesn't change. Now I add them. The C's cancel. 2T equals 60. That means T equals 30. So we know trucks, there's 30 of them. Now cars. Cars, if I take the 30 and plug it in, I can plug it in anywhere I want. I'm going to take the T and plug it in right here. 2C plus 5 times 30, that's 150, equals 90. I subtract 150. 2C equals 40, so C equals 20. So that means there are 30 trucks and 20 cars. In example 3, on the Got It on page 249, you will notice that everything is in standard form, so everything is aligned. Step 1 is done. Step 2, nothing cancels, so we have to multiply. So look at your x's. What does a number both 5 and 3 go into? It'd be 15. So you could make one of these negative 15 and the other one positive 15. However, you'd multiply a number to both equations. So let's look at our y's. What could you have here as a number, a coefficient, that 6 and 2 both go into? You may think 12, which would work, but 2 and 6 go into 6. So this one is 6. This one would have to be negative 6. So what would you multiply the negative 2 to get negative 6? It would be 3. So to me, that would be easier. Now, if you wanted to get rid of your x's, you can. This is completely up to you. So let's multiply the first equation by 3. Negative 15x minus 6y equals 18. The second equation does not change. Add them together. Negative 12x equals 24. Divide by negative 12, x equals negative 2. Let's plug it in. This one to me looks easier. I'm going to plug it in for x. 3 times negative 2 is negative 6, plus 6y equals 6. Add 6. That gives me 6y equals 12, which gives me a value of y equals 2. So my answer would be negative 2, 2. Example number 5. Look at it yourself and see what would be easiest to get rid of. X's or y's? Maybe the y's. What could you multiply the top equation to get at the opposite of the bottom? It'd be 2. Because then we get a positive 2y and a negative 2y. So we get 6y would be 6x. 6x plus 2y equals 10. 2x minus 2y equals negative 2. And why don't you solve the rest on your own? If you solve the rest on your own, you would get x equals 1 and y equals 2, which gives you the ordered pair 1, 2. In the problems in example 4, in this section, you're going to be multiplying both equations. So once again, look at this equation. Everything is lined up in standard form. I have to make something cancel. If you want to get the x's to cancel, you could get a number such as 12 and negative 12. If you want to get the y's to cancel, the first number 3 and 2 both go into is 6. I think the y's would be easier, not only because the common multiple is lower, but because one is already negative and one is already positive. So I'm going to multiply. If I want to make this 6, if I want to make that a 6y, I'm going to multiply the top equation by 2, and I want to make the bottom equation negative 6y, so I'm going to multiply by 3. So multiply both equations. 2 times the top equation would be 8x plus 6y equals negative 38. The bottom equation would be 9x minus 6y equals negative 30. Add them together. 17x equals negative 68. Divide by 17, x equals negative 4. Plug the x back in. I'm going to plug it into the top equation. And I'm going to finish this on my own here. If you finish this equation, you're going to get negative 4, negative 1. Example number 7. It's all in standard form. Everything is aligned. What do you think on your own would be the easiest to get rid of? The x or the y's? Either one would be fine with me, but the y's would be the easiest because I can make one of them 12 and one of them negative 12. I'm going to make the top negative 12 by multiplying by 4, and the bottom positive 12 by multiplying by 3. So if you do that, you're going to get those two equations. I add them together. 45x equals 90. X equals 2. Plug it in, which I'm going to do. I'm going to pause the video and do it myself. You should get the answer of 2, negative 1. The got it problem on page 251. So, everything is lined up. Will anything cancel? No. So let's make, it doesn't matter, x or y. I'm going to multiply the bottom equation by negative 1 to make that a positive 2x. So this top equation does not change. The bottom equation becomes 2x minus 5y equals negative 12. Step 3, add them together. X's cancel, oh, but so do the y's. I'm left with 0 equals negative 5. That is not a true statement. Therefore, this problem has no solution. And the last problem we're going to do is number 9. Look at this. I'm going to multiply the top equation by 2. That'll make the y's cancel. So that would give me 10x minus 6y equals 20, and the bottom would stay the same, plus 6y equals 20. Now, it looks very similar to the one we just did, but the x's don't cancel. The x's give you 20x equals 40, x equals 2. I plug it in, so I'll plug it into the second equation. That gives me 20, that's 10 times 2, plus 6y equals 20. Subtract 20, 6y equals 0, therefore y equals 0. So my answer would be 2, 0. Now let's go back to this problem here. Let's say you ended up getting 0 equals 0. That'd be true. Therefore, you'd have infinitely many solutions. So I'm glad you enjoyed your time with me today, listening to how to solve systems using addition method or elimination. You now have 3 things underneath your tool belt to solve a system: graphing, substitution, and the addition method, otherwise called elimination.